Hello. In this module, we are going to talk about Kafka overview. We'll have an idea what is Kafka all about. If you happen to heard about Kafka before or you have some doubt what really does it, this module will help you to understand what Kafka is and what it does for the enterprise application. First of all, before we go to the understanding where all we use it and what is Kafka, so let's try to define the Kafka in a very logical, technically. As for the Kafka website, the Kafka is a fast, scalable, durable, and a fault-tolerant publish subscribe messaging systems. So, first of all, the intention of the Kafka is to provide a messaging systems. So you might have heard about relational database management systems where you store data for the future reference or for processing of data, or if an application wants to insert the data or store the data for a longer period of time, then we store the data in the database management systems. So likewise, the Kafka is a messaging systems. So it's a little bit same with the relational database management systems. Yes, it has RDBMS has a lot of capability, especially the asset properties. However, in terms of the storage, you can compare that Kafka, the relational database management systems and the messaging systems are more or less the same. They are just a storage. But it has its own capability. But for the time being, if you're quite new to the messaging system, just imagine that this is a place where you can store a data. Now, coming back to the publisher and subscriber, there is the your application will be able to push some data that's called the publish, and then it will be able to consume the data from that particular the storage, which is your messaging systems. This is called the pub and the sub. So like for example, in your e-commerce domain, say in Amazon, when you place an order information will go out here in this messaging systems, which can be a Kafka. And then your SMS application will be sending the order detail to the customer using the data that's stored in this particular messaging system. That's called the publish subscribe. We will go into more in detail as we move to this the course in Kafka. And now is a fault tolerance. So in case if the disaster happened or something happened, your system crash, you will be able to recover that data with a concept called the replication, which is again we'll go more in detail when you move down, when we move across these the course. It's durable. The information that gets stored in the file, so it can after you power off your systems, then the application, the data will be still available for your application. The another beauty about the Kafka is scalable. When you said scalable, means that is you can deploy the Kafka in multiple machine, so it can scale it out. So it's a scalable. So the difference between the other messaging systems as compared to Kafka is the scalability. You can scale it out, and then it's very fast in the nature. Okay, we'll talk about why the Kafka is fast and what are the design behind that differentiates the Kafka with other messaging system. Will be more in detail when we talks about internals of Kafka later on. Now, in order to understand the Kafka uses, the Kafka is so prevalent in the market. So some of the statistics that I just want to show you out here is that 40% of all the Fortune 500 companies uses the Kafka. So that means it's been used across the different domain. used in travel companies, banks, insurance, telecom companies. So that means it's the uses of the Kafka is scattered across the various domain. So when this means is that is this is reliable and it works. It's been proven that LinkedIn, Microsoft, and Netflix and all process the millions of messages a day using the Kafka platform. So that means the kind of the message that the Kafka can process is tremendous, and it has been proven when they deploy in LinkedIn and Microsoft kind of platforms. What are the applicable scenarios where we can use the Kafka in application is that is, for example, if you want to know that Kafka fits to your environment or not, is if you if it falls in this category, then definitely you can use Kafka in your application systems, like real-time streaming of data. If there is a continuous flow of informations to your app in the real time and you want to react to that, like for example you're placing an order in an e-commerce app, then for each of the order it comes at, users want to act to the customer by sending an SMS. Then you want to inform to the customer that we receive an order on in the real time, then the Kafka is the right candidate for you. Or you have a lot of data collections, or you have a lot of different data sources, and then you want to dump this informations to say some Hadoop or big data solution, where in turns you can create data warehouse out of it. So whatever data that are generated in different sources, the sources can be, this can be your relational database management systems, like say Postgres or any relational database, or you can use the MongoDB for your applications, or you have an IoT devices that generating some events. So all that information that's generated, you want to dump in one place, and you want to generate a report out of it, or you want to create a visualizations, or you want to run the AI, or you want to run the ML process on top of it, then this is the right solution, or you can deploy for that to bring the data from different sources which are generating data in the real time and dumping in your data warehouse or big data landscape. Or you want to do both, it means you have the real time data coming together as well as you want to process the data on the real time. So that's right candidate for that. Let's try to see in the next slide about the applicable scenario which are predominantly uses in the industry. One of the main category where industry uses the Kafka is in the microservice environment. In the last for the last 1 years, I'm doing consulting and training for one of the e-commerce domain, where they extensively use the Kafka for the microservice deployment. It's an e-commerce domain organization where they place where they use extensively Kafka for the exchange of informations across the systems. So for the people who are new to the microservice environment, let me just give you an idea. What does it mean? That is, suppose if you develop an e-commerce application, okay, if you develop an e-commerce applications, and it has a module called the customer module that take care about customer registrations, or you can update your profile, or you can update your address and a kind of stuff, payment detail. Now another part of the application is the order processing. You are accepting the order from the customers, and then you may have some delivery department where they delivers the orders to the end consumer, and then you may have the marketing department that do the advertisement and marketing of the product. So you may have different module in that. The traditional way of developing such kind of enterprise application is that is you develop everything in one app. That is called the monolithic. Okay, monolithic. Monolithic means is that is you are going to bundle the whole app in one app. So usually, if it is a JE application, you people used to deploy as a WAR or the EAR, depending upon the kind of platform that you have it. What is the challenges is that is when you deploy every application as single, then whenever there is any change in any one of the module, then you have to deploy the whole application, and then that's a challenge for that. Another one is that is if I want to use, say, for transactional order uh, to be inserted, the data pertains to the order in a Oracle databases, because I require the transactional systems for the order to be maintained. What about for the delivery? We want to utilize a NoSQL like MongoDB. Then it is difficult because when you have everything in one place, then it is difficult to mingle or mix and match the different types of platform for a single app. So the another way of designing the SAM application is that is you divide it into multiple services. So for in this cases, we can have the customer services differently, the service that pertains to the order separately, and the delivery can be done on the separate services, or the marketing can be done on the separate services. So what is the advantage is that is for these services, I can deploy a different platform. I can use Node.js and MongoDB for this particular platform. For these, I can use the JE Spring Boot plus the PostgreSDB. For these, I can use the Couchbase. So depending upon my application requirement, I can change the platform. And advantage now here is I can deploy this app separately, and I can develop the application separately. So it's the ease of use and development. So there are a lot of advantages that you have it when you deploy your application separately. Now, when it solves the problems of having a different platforms and scalability and kind of stuff, now it creates another problem. How do I pass on the information among them? If I have to send the customer information from this customer module to my order, then we have a challenge. So earlier, people used to deploy such solution using the web services, but again, it tightly coupled again. So now the better advantage is that is I put a layer here now. That is called the messaging systems. So now what I do that is customer will send the information to this guy, and this guy will pick it up from here. So this advantages is provide a lot of that dependency between the two, that is the customer services and the order services, is now transparent by putting one layer called the messaging system. This is what the Kafka is doing right now here. So look, coming back to this Kafka now, having understand the difference between the monolithic and the microservice architecture. Now in this example, we have deployed the Kafka as a messaging systems. As I told before, that the Kafka is as a storage. So just imagine for the time being, it's a storage. It has a lot of capability. We'll talk about it later on, but for the time being, just imagine it's as a storage. So I have an application called order services. This is just a service, and it exposes one REST API. So a consumer create an order. An order can be in a JSON format. So it can be an XML format, or it can be any format that you have. It can be in an object, or it can be anything as long as it's in the form of bytes. The information comes to this order. Now, what happened is this order information gets stored in this particular locations. Like in the messaging system, again, we can create the different compartment. Like for example, in databases, we have a table. So this is one of the table. Yes, sometimes you can refer this as an individual databases, or it can be a different or individual table inside the database. It doesn't make any difference. It's just a namespace for storing your data. Now, when I place an order information in this order storage, now I can have one email service here. So now whatever order I receive on this particular storage, I can send information to the end customer using the information contained in that particular message. Now, if one of the service like inventory wants to manage the inventory, keep track about the order ID and what are the items that have been ordered in this particular order, then this service again can pick it up. Now, I can add as much as services I want. That will be depending on this particular data of order. But now I don't need to have direct conversation between the order service and the inventory service. So now the dependency among the services remain transparent by placing this intermediate layer. So now you can plug and play now. So I can now I can have one more different version of other services, different order. But like for example, this is accepting the order from the web, or this is accepting from a point of sale. Then what happened now is I can insert it here and someone can consume it. Now even I can send this information to an Elasticsearch here so that we can have a visualization of the data. So Kafka is used extensively when you deploy microservice environment in an enterprise application in order to remove the tight decoupling of the services when you deploy the microservice environment. So Kafka used extensively in deploying the microservice environment. Now, another uses is of the big data landscape. In this example, you see that there are different data sources. Like, say, for example, you have the still will apply with the same scenario that we have seen in the microservice environment. Like, for example, we are accepting order from the mobile, from the web, and IoT is also generating some information. Even like, for example, from the warehouse, if inventory comes down at a certain level or some temperature for the particular item, if he wants to generate some event and informs to the centralized location, we just generate an event. And an event can be a message, is as a data. However, if we talk in the messaging system, we usually use the word called event or a message. Okay, it's just an information or data generated from a source data, or it can be generated from, say, from a cloud provider like Amazon or on-prem data source. Now, using some connector that we'll talk about later on, where there is some program that posted informations to the centralized messaging systems. Here is the Confluent Kafka. The Kafka comes in two flavor. One is open source, and another one is from the Confluent. And now in this example, we are deploying the Confluent Kafka. Now the data get pushed from the data source to the Confluent Kafka, and then it get consumed by your data platform. Say, for example, this is your big data platform like Hadoop, or it can be from your Amazon, like Amazon S3 buckets, where you store it, you push it. Now, this program that push the records to the messaging system is called the publisher, and the data that the application that consume the message or data from here and then push it to the another sync is called the subscriber. Okay, and then you can perform your visualizations or analytics or transformation if you use Spark, or you can use the Kafka Stream or any other processing engine on top of that. Yes, if you have noticed that there is one called schema registry. This will talk in the further modules where you can define the schema, or you can define the schema of your data. For example, if you want to insert an order, you can say that my order need to have should have a value called order ID with a data type called the integer, and order value should be of the double. So I can define the schema of my data in the schema registry. We'll talk about it in the subsequent module. And you might have noticed this KSQL DB is it allows you to extract data from the Kafka using a SQL kind of syntax. So this is an advanced feature. So I'll be having a separate module that talks about the schema registry and the KSQL DB later on. So we have seen that where do we use this Kafka. Okay, now why we need a Kafka, where all we can apply the Kafka in our environment. So it's like, how do I use it in which particular scenario where I can apply the Kafka? Is that it can be used in any real-time streaming data or real-time analytics. So you are receiving a continuous flow of data, and then you want to react on that. Then on the real time, not as a batch, then Kafka is an ideal situation for that. For example, like a service call, tracking every call that you receive, or any IoT sensor. Like for example, you have deploy some applications in the warehouse, and when the temperature fluctuated in the warehouse, you just want to inform to some analytics engine, then you can use Kafka for that. Kafka is often used instead of JMS, RabbitMQ, and MQP. There are different ways of deploying your messaging systems. Okay, this is Java based, and this is based on Erlang, and this protocol follows the AMQP protocol. These comparisons of Kafka with the other messaging system will be covered in the subsequent module. This is just an overview what we are having it. Kafka has very high throughput and reliable, and it can also perform replication. That means the same copy of data can be replicated among the different nodes. So when one of the node fail, you can still recover the data. So that is the beauty of Kafka as compared to other messaging systems. So more in details about the uses you can use in any real-time streaming applications. Nowadays, I often see that a lot of clients get deployed with Kafka here. That means from the e-commerce domain, you push the data to Kafka. For further downtime, we have for transformation. You can use extensively with the Kafka stream, which I'm going to talk in a separate module, more in detail. Then people apply with Spark, and another one that is very famous nowadays is a Flink. So I'll be covering a separate course on Flink. So if you're interested for that, you can look for it later on. Now, it's used in a real-time data analytics. That means if there is a requirement to monitor how many sales happens in the 5 minutes, and then your business owner wants to see that how many sales happening every 5 minutes, and it has to be reflected in the dashboard, then Kafka is the right candidate for that. You can apply transformation on top of the data using this ways of doing it, and we'll see to that. And you can even use for complex event processing. That means you want to see the patterns of the events that happen. For example, if a login happened and then subsequently it has to be log out, so that kind of patterns, if you want to monitor it, you can apply. You can use this with the Flink CEP that is extensively used in various industry. You can fit to the data lakes where you can dump your data for further processing. And you can even use for building the real-time streaming data pipeline. That means you on the fly, you want to transform the data from one format to another in the in-memory without doing the further transformation, which you want to do in the application itself. So this is a right way. This is a way of handling that kind of stuff. Now, then you can ask me now why the Kafka is so popular. Okay, so we have learned what's Kafka, where it is being used. Then we talks about the bit about the where are its uses. Now, why the Kafka is so popular as compared to other messaging systems? It's give the great performance to that. So the performance is the main reason why the Kafka is an ideal for a lot of messaging systems. I'll talk about more in this detail in the next slide, where we talks about how the Kafka provide performance when you have a large number of messaging to be processed. It provides operational simplicity and easy to set it up. In the subsequent module, we are going to deploy the Kafka. Then it's just a few steps to do. Like for example, you just need to install the JDK and you just extract your Kafka. That's it, nothing more than that. Then you configure some parameter if you want to do. Otherwise, if you want to deploy with the default value, then you can just bring up your Kafka in a fraction of, so I'll rather say by 30 to 60 minutes, you can bring up a one Kafka immediately under that. So it's very easy to configure and easy to use for that. It's stable. It has been in the industry for quite a long time, and it has been deployed in various industries. So it's reliable and it's durable. So you don't need to worry about that you will get the lost data, and also that kind of problem will not be there. It has a very flexible concept called publisher and subscriber, which we'll talk later more detail. And it can also design the queue, although technically it doesn't support queue, but then using the concept called the consumer group, you can design the queue structure in that. We'll talk about that. That's queue means the first in, first out kind of. So that means you push a records to your Kafka messaging system. It will be consumed by only one consumer. So once it get consumed, the second consumer cannot consume the message again. This can be only deployed with the concept called the consumer group that we'll talk about later. And it has a robust replication. That means the same data get copied in multiple places, so that in case something disaster happen in one of the node, it can be picked up from another node, so you don't lose your data. It works well with systems that have data stream to process, so it's integrated well with a lot of streaming platform like Flink. Then we have Kafka Stream, and it's also integrated with the Spark very well. So we'll talk about this later on, and I'm going to have a separate program for Flink and the Spark later on. Now, coming back to that, the Kafka has a great performance, and how it makes that is that the one concept is called zero copy. Zero copy require it's a bit more in details. This I'm going to cover when we talks about Kafka internal. For sake of understanding for timing, it's when you copy the data, that it doesn't goes to the multiple the clock cycle. So that is the advantage that you have. That means the data that you copy from your disk by the CPU, that the system kernel, they get passed on back to the network without passing on to the application buffer. So that creates that saves the CPU cycle. So that's the advantages that you have it. So I'm going to talk more in detail about zero copy. So this is like that. Is whenever you pick it up data from a file or from any storage on the disk, it needs to pass on to usually pass on to the application buffer. So when you pass on that data to the application buffer, it's consume the clock cycle. Instead of that, it just store and pass on the same context of the kernel, and then pass on to your application layer. Sorry. So zero copy allow you to improve the timing, that and the latency. So it gives you the low latency as compared to others. So I'll talk about more in detail in the internals of the Kafka in a separate module. Now, when you have your messaging system here, and then your app, say for example, this is your order app, you are receiving a lot of orders and you are trying to push it to the Kafka. Instead of sending the record one by one, what the Kafka allow is you can batch 5 records and then push it. So it's batch the data into chunks, so that gives you faster, because instead of opening and sending one by one and then you keep track about it. So at one point you can send that. You can specify in terms of size. You can even specify in terms of time to batch the data. So that means I want to batch around 50 MB of data while pushing, or every 5 milliseconds I want to push it. So whatever data is there at the time, then you can even define the buffer size for this. So these are the configuration that you can do. I'm going to cover all this more in detail in the separate module when you talk more in detail further down. Then there has the sequential disk write. What does it mean is whenever you write the data in the messaging systems in the Kafka, it internally write back to the one log file, which Again, I'm going to go more in details about this log structures. You can even read the logs. There's a concept called offset and all that. You can even view that how the data gets stored inside this log file later on when you talks about more in the internal. Now, when it gets stored in this log file, what it easily does that is Kafka will keep on appending it. It will not do any random access. So what is the advantage out here is that since you're going to store the data or append the data in a sequential manner, that then what happened there is that is the application doesn't need to keep track too often. It knows that there is a pointer. So when the next record comes in, it will write in the next offset. So offset is the next byte that the space is there, so you will write to that. It doesn't look for a scan and then you do that. Whereas in database, the scan is sick for it and update it. So this is called sometimes called the append lock. Append only lock. Okay. Now another advantages that Kafka provide for providing the performance is the horizon to scale it out. That means when I have when my application doesn't have too much data, I can use only one node, and say for example this can handle the 5 GB of data hypothetically. Now if this exceed, what I can do is then I can add one more node, and I can add one more node that has a capacity of 5 GB or 5 GB now here. So what I can do is that it when my publisher application write to that, I can write parallelly to that. So when I scale it out, I have multiple record can goes to the different nodes, and write can happen parallelly, and this is possible using a concept called partitions that we are going to talk later. That's it about the introduction overview about Kafka. I hope you have some idea what Kafka is all about, what it does it, and where will you use it. In the next module, we're going to talk about the Kafka architecture in detail.